channel. So today we are going to start with a new topic named Kepler's laws. Okay, see what has happened. Before Newton, it was Kepler who has given planetary motions, but he didn't know why the planets are moving in this particular pattern. Okay, so he gave 3 laws of the planetary motion. So we are going to look at those 3 laws. Later on, the Newton came, and with his theory of gravity, he could derive these laws of planetary motion. Fine. So what are the 3 laws he gave? The first law says that every planet revolves around the sun in an elliptical orbit with sun at one of its foci. Now for this we need to understand what is an ellipse. Okay, first we are going to see what is an ellipse. Suppose I take this cone. Fine. This is my cone, and I am going to cut this cone at an inclined plane. Now what I mean by an inclined plane. So I get a curve like this. Fine. What do I mean by the inclined plane? See, this is my flat surface. When I raise this flat surface to a particular angle, that is known as an inclined plane. Okay, so this plane is raised at a particular angle. So when I cut the section of a cone like this, so what is left for me now? See, I am cutting the cone like this. Fine. Basically, it's like this. Okay. So what I can see, this curve is called as an ellipse. Okay, this curve is ellipse. Fine. Now this curve has got particular properties. What are the properties? Now I'm drawing an ellipse here. It always has a major axis and the minor axis. Fine. This is my major axis. This is my minor axis. Now it has got 2 foci. What are foci? Now suppose I am taking this F1 and I am taking this F2. This is my center. These foci are nothing but the points which are at equal distance from the center. Okay. This point is at a distance x. This point is also at a distance x. So they are called as the foci. Now what is the special property of this foci? Suppose I am taking any point A here. Okay. And if I am going to take the distance of this A, point A from F1 and F2. Let me do the addition. Okay. The distance of from the first foci is AF1 plus AF2. It's always going to be a constant number. Let me take any point on the ellipse. Suppose I am taking this point B. So I am taking this point's distance from F1 plus F2. Again, it's going to be a constant, same constant number. Okay. So this is also going to be equal to BF1 plus BF2. So this is a particular property of the foci. So foci are the points which are at an equal distance from the center. And what else is the property of the foci? That I take any point in an ellipse, the distance of that point from both the foci, okay, and the addition of those distances is a constant number. Okay, so I have to remember this. This is the most important property of an ellipse. Okay, so what first law is saying us? Now, the first law is saying me that suppose a planet is revolving in an elliptical orbit. Okay, every planet revolves around the sun in an elliptical orbit. Okay, this is my planet with sun at one of its foci. So suppose my foci is this F2 and this one is F1. Okay, so either this F2 would be sun, right? So what it's saying, that every planet is revolving around the sun with sun at one of its foci. We have to always remember that. Fine. Okay. Now what next it's going to tell us? So suppose I have another, this was my first law. Sun at one of its foci. Sun at one of its foci. Now second is same. In what it says is every planet sweeps equal areas in equal interval of time. Suppose with respect to Sun, okay, this is my Sun at one of its foci. I am taking the motion of the planet from point A, okay, and I am considering that time to be T. Okay, suppose I consider that to be 20 years. Fine. So this after 20 years, this planet is reaching the point B. Okay, and same, if I am considering same time period, okay, T is equals to 20 years, and when the planet is starting its motion from the point C, after time 20 years, it's going to reach the point D. The second law tells us that these areas are equal. Okay, what it says that this area, the planet sweeps equal areas in equal intervals of time. So it's saying that the area ESB is equals to the area CSD. Okay, fine. So that was the second law. Now the third law is what? The third law tells us that the time of revolution of planet around the Sun, suppose I denote it with T, its square is directly proportional to the cube of the mean distance of the planet from the Sun. So if time duration of revolution is T, okay, and T is the distance, mean distance of the planet, distance of planet from the Sun, planet from Sun, okay. So it says that T square is directly proportional to R cube. Okay, now how are we going to use this? Okay, so let me consider the motion of the planet to be a circular motion. See, I am considering the motion of the planet to be a circular motion, and let Sun be at a center S. Okay? So if I have a circular motion, that means V is equals to the distance covered is what? What is the circumference of the circle? That is 2 pi r upon T. This is the formula for velocity. Velocity is what? Distance travelled upon time. Upon time. Okay? As it is a circle, circumference of the circle is 2 pi r upon T. Now if I have a circular motion, that means a centripetal force is acting, okay, on that planet. That centripetal force is provided by the Sun. Okay? So that force is nothing but mv square upon r. Now what I have V as? I have got V as, let me do the square directly. Okay, V square is going to be 4 pi square upon r square upon t square. Okay, so this is, okay, so this is giving me like this. But what is my t square equals to? My t square is equals to r cube, right? So what it gives, it shows that f is inversely proportional. Okay, it is showing that f is fine. This t square is nothing but r cube, right? So it is showing that f is inversely proportional to r square. Later we are going to use this. Newton, what he did, he, according to the Newton's law of gravitation, which we would study in coming video, that shows that the force of gravitation is inversely proportional to the distance. That inverse proportion he got it from the Keplers law of planetary motion. Okay, Kepler's third law indicates that the t square is directly proportional to r cube. That he used it in the centripetal force and he got the inverse relation. Okay, fine. So these were the things which we were supposed to discuss. Usually it's asked in the examination, write the 3 laws of planetary motion. So that time you have to describe all these laws. Okay, so thank you for watching my video. If you like my video, do give a thumbs up, subscribe to my channel and do not forget to share it with your friends.